awaken in a forest and notice something is not quite right. First off, you live nowhere near a forest, yet here you are. The moon never before seemed to glare at you so hard that it gives you the worst headache of your life, yet, once again, here you are. What do you do? Do you succumb to the pain? Try to block it out? Or 3, stay tuned to figure out how to make your own text-based adventure game. To begin our lesson on Python, you're first going to need a method to actually write Python code. The good news is, you have a number of different options. You have Notepad, you have Vim, and you also have what I have on the screen here, Pycharm. Pycharm is a specialized IDE for developers. And the good news is, they have a free community version for you to download and go along with this course. Once you go to this website, download Pycharm, install it. What you're going to be greeted with is this window here for our new project. Inside this window, you have a number of different options. You can create a pure Python application, like what we're going to be doing, Django, Flask, and even some other programming languages. We can give any name that we want, and we can specify the location where all those files will be created. The thing I like about Pycharm is that by default, Python virtual environment will be created in the project root. Virtual environments allow you to be able to separate your projects and their dependencies from each other. Let's say you have a project that requires request version 2, and you have another that requires request version 3. Well, those two projects are using two different versions of requests because they both have their own virtual environments which control their dependencies. Once everything is to your liking and you click OK, you're going to have a freshly created Python project that we will use to follow along with this course. Let's begin our lesson in Python by discussing variables and types. To start, Python is what is considered a dynamically typed language compared to languages like Java and C++, which are static type. What this means is that variables in Python can change from one type to another over the course of an application's lifespan, as opposed to languages like Java, where a variable has a type like int, string, or char, and it can only hold a value of that type or a value that can be typecasted to that type. When it comes to types in Python, all variables are considered objects. Let's discuss how we go about declaring a variable. To declare a variable, you need to have a variable name, like what you see here with current year, equals, followed by some value. What we're doing here is creating an integer. Current year equals 2024. On the next line, I'm going to print out the type of current year. And I have the output right here as well. What we see here is class int. In Python, variable names are symbolic, meaning they're just references or pointers to an object that gets created. To go over our integer creation in more detail, what we're doing is we're creating an object of class int, as we see here, and assigning it the value 2024. A reference to this object 2024 is then stored inside of this variable that we call current year. From this point forward, if we wish to use the object 2024, we just simply use current year. So once again, to reiterate, on line 6, we're creating an integer called current year. On line 7, and we're printing the type of our variable current year. To get the type of any variable that you create, you just simply use the built-in function type. The explanation that I just gave, you can just replace integer with float, string, boolean, list, and a bunch of other types that Python has. Here I've just declared some of the more common ones. Some of the more common ones, you have, of course, integer, as we've already discussed, floats, strings, booleans, lists, dictionaries, and a bit more uncommon, tuples. We'll go over these one by one. An integer just represents a whole number. So 2024, 1, 2, 3, so on and so forth. A float represents a decimal number. So for instance, we use pi and give it the value for pi, which is 3.141592, so on and so forth. Next is a string. We have our string slogan, which we give it the value, get ready for the next battle. To declare a string, you would simply use double quotes or single quotes, and anything inside those quotes is going to be considered a string. Next, we have our Boolean type, which only has two values, true or false. Next, we start getting into the more interesting types. We have our list type here, where we've created a list named current game list. To create a list, we use these square brackets, and anything that is inside of here that is comma separated is a part of that list. You can have a list of strings, a list of integers, a list of floats, a list of objects, which we'll cover shortly. But you can also have a list of mixed items. And what I mean by that is, you see here, we have a list of strings, but I can also add an integer and a Boolean, and this list is totally valid. It might not make much sense, but it's still totally valid. In order to access individual items in the list, we use what's called an index. For instance, let's say we want to print the first element in our list. So print current game list, square brackets, 0. What this is saying is, in our current game list, reference the index 0, which is basically another way of saying, I want the first element in my list. The reason why we use 0 is because in computers, we start with 0, not 1, like humans would normally do. So we have index 0, index 1, index 2. What this statement here on line 23 will print is just simply the game chained echoes. Once again, to reiterate, in order to reference individual elements in a list, we're going to use something called bracket notation, which is just simply, we have the name of our list. Using brackets, we're going to specify which particular index we want to reference. Let's go over our next type, which is the dictionary type. To create a dictionary, we of course have our variable name, which I've chosen game info, equals, we use curly brackets this time, and inside you'll see a bunch of different properties that this dictionary has. Compared to lists, which use numbered indexes, dictionaries use key value pairs, meaning in order to reference anything inside of our dictionary, we're going to use the key that is associated with the value. The key is on the left side, colon. On the left side, we have our value, which creates our key value pair. Similar to a list, as we discussed earlier, we're going to use bracket notation in order to reference whatever it is that we're trying to access. So for instance, I want to print out to the screen game info key name. So what's going to be printed out from the screen here is game info, which is our dictionary right here, index name, whatever is associated with the key name, which is in this case, chained echoes, and we're just going to print that to the screen. Similar to lists, dictionaries can contain a number of different values. So for instance, name is a string, year is also a string, but I can also make this an integer. Description is also a string. Miscellaneous is another dictionary, which has its own individual key values. Lastly, we'll cover tuples. Tuples are an unchangeable, ordered collection of values where duplicates are allowed. To denote a tuple, we use parentheses. Similar to lists, tuples can contain any types of values that we want. So I have a tuple named colors, where I have red, green, and blue in thus far. But I can also add the number 3 in there, and this is totally fine. Earlier I stated that tuples are unchangeable. What that means is that once a tuple is created, it cannot have values added or removed. Now, these are a few of the value types that you will find in Python, the more common ones, but there are also many, many other ones. For instance, there is a complex type, which is used to represent imaginary numbers. In this section, we're going to cover operators and expressions. In Python, operators are one or a combination of special symbols or keywords that designate some form of computation. We can combine objects and operators to form expressions. Think of operators as the building blocks of expressions that allow for the manipulation of data in Python. Operators are either unary, which means taking in only one operand, or binary, meaning taking in 2 operands. In Python, there are a number of different operators. We'll go over those types of operators now. First up is the assignment operator, which we should already be familiar with. The assignment operator creates a reference to a concrete object and attaches that reference to the target variable. As we've gone over before, whenever you see variable name equals some value, like for instance on line 4 here, what we're going to do is instantiate an object of class int, which is basically just creating an object of the int class. We're going to take that object and create a reference to it and store it inside of the variable name num1. We do the same thing on line 5. We're just creating an object of class int, giving the value 3. We're going to take the reference to that object and then store it in num2. Simple, right? Next, we have arithmetic operators. These operators allow for you to perform arithmetic operations on numerical values. So basically, addition, subtraction, multiplication, division, basic math that you learned in preschool. First off, we have on line 9, summation equals the sum, which is denoted by, of course, the plus sign, num1 plus num2. On line 10, we do the difference, num1 minus num2. Product equals num1 times num2. Next, on line 12, quotient equals num1 divided by, denoted by a forward slash, not a backslash, that means something different, num2. On line 13, remainder equals num1 modulus, denoted by the percent sign, num2 returns us, of course, the remainder. Now, this can be a bit tricky if you're not used to seeing this in programming languages. So, Let's imagine num1 is 5 and num2 is 2. Quotient equals 5 divided by 2. 5 divided by 2 is 2.5. The remainder, however, when we're doing modulus division, 5 modulus 2 is going to equal 1. Why is that? Because what you essentially have is 4 going into 5. 5 minus 4 is 1. So 1 would be your remainder. That 1 would get stored in your remainder variable. On line 14, we have our variable negative, and we assign it the negative, or the inverse, of num1, which would be 5. So making that negative, we assign negative 5 to our negative variable. You can do the same thing on line 15 with a positive number, but by default, numbers in Python or any programming language, at least the ones that I've used, are positive by default, unless you specifically say, of course, they're negative, which is denoted by, once again, the negative sign. Python also allows you to take the exponent of two numbers as well. If you've taken calculus before, this should look familiar. What you're saying here with this expression is num1 to the power of num2. Num1 is 5, num2 is 2, so what you're basically saying is 5 squared. Next, we have our comparison operators. Comparison operators compare numerical values and any other objects that support them. Here, we see a number of numerical comparisons. We're going to print to the screen, does 1 equal to 1, which is going to be true. However, as I said, you can compare other objects that support them. So for instance, does the string A equal to the string A? This will come out to be true because the value are the same. In summary, with the equal to operator, all you're doing is simply checking to see if two objects are equal to one another. Equal to one another meaning their values are the same. The inverse of that, or the opposite of that, would be the not equal to operator, denoted by exclamation mark equal. Exclamation mark is basically a way of saying not. So not equal. In the statement on line 23, we're going to print out if the number 1 is not equal to 2. That is, of course, true. So true would get printed out to the screen. We have our less than operator, which is denoted by the less than sign, of course. On line 26 here, we're going to print out if 2 is less than 4. That is, of course, true. On line 27, we're going to print out is 5 less than 4. That is, of course, false. A variation of the less than operator is the less than or equal to operator, which is denoted by the less than sign and equal. On line 30, we're going to print is 5 less than or equal to 4. That is, of course, false, so we print out false. However, part of the or equal to portion of our operator, on line 31, we print is 4 less than or equal to 4. This is, of course, true because 4 is not less than 4, but it is equal to 4. Next, we have our greater than sign, denoted by the greater than operator. Line 34, we print is 4 greater than 9. That is false, so false would get printed. Line 35 is 9 greater than 4. That is true, so we print true. Similar to the less than sign, greater than also has a variation called greater than or equal to, denoted by the greater than operator and the equal operator. Line 38, we print is 4 greater than or equal to 9. The end result is us printing false to the screen. Similar to line 31 up here, we print is 9 greater than or equal to 9. This is true because 9 is equal to itself. Our next class of operators will be the Boolean or logical operators, of which we have 3. We have and, or, and not. Now, and or are binary operators, meaning they take 2 operands. Expression 1, expression 2. Your expression can be anything. It can be a simple comparison, like so. Our first operator was the and operator, which is denoted by the lowercase word and. In the comment that I put on line 25 here, expression 1, operator, expression 2. This is the basis for both and or operators. What we're saying is, given expression 1, this will be our expression. We're checking if choice is equal to an empty character. If that is true, and if choice is also an alphabet, if both of these are true, then we're going to do whatever is inside of this if statement here that we have. To put it simply, given our and operator here, we're only going to do something if expression 1 evaluates to true and expression 2 also evaluates to true. If either of these are false, then we don't do anything. One thing also to note is that there's a bit of a speed hack, so to speak, with and operator. If the first expression is false, there's no need to check the second one. It's going to be false. So we have no reason to even check it. Now, if we make this or can be seen as a bit more forgiving. With or, we're going to execute whatever our statement is if either of our expressions evaluates to true. Meaning, if our choice is a blank character or choice is an alphabet, means we're going to print our statement on line 27, and we're going to ask the user for another input if choice is either a blank character or is an alphabet. So the only way for us to not do this and go on to the next portion of our code would be to input a number or a special character. Now, the not operator, which is the last operator that we'll go over for this section, not is urinary, meaning that it only has one operand. Not is basically the inverse of whatever our expression evaluates to. So let's say that you as a user, you input an alphabet. Look at it as if this not isn't here for right now. What we're saying is if choice is an alphabet, which you've given an alphabet, let's just say your choice was A. Choice is true. Choice dot is alpha would evaluate to true because you gave the letter A. Not comes in and inverses that and makes it false, meaning we don't execute this line here. We just move on. To put it in the simplest way possible, if your expression is going to evaluate to true, not is just going to make it false. And vice versa, if your expression evaluates to false, then not is going to make it true. That covers the Boolean or logical operators, so next we'll move on to the identity operators. Identity operators check if the operands refer to the same object in memory. To make that easier to understand, I've put the simple sentence here, and where you see these 3 underscores here, you can replace with the identity operator is or is not. The statement reads, check if operand is the same object in memory. Likewise, is not, check if operand is not the same object in memory. One very common use of the identity operator is not that you'll see is in comparison with none. None reads as the sole value of the type none type. So long as next seen does not equal none, in other languages is called null. So long as next seen is not none, we're going to continue to get scenes. Now, since in my code I'm not using is, I've created a few examples here. On line 48, we create a variable called num1 and assign it the value 2. Line 49, we create another variable and assign it 2. Print num1 is num2. This results in true. Now in our next example, you see that we change num1 and num2 to both be 300. However, when you print num1 is num2, we get false. Why is that? That is because Python does something pretty cool. Any number, any integer between -5 and 256 gets cached. What that means is, since we have 2 up here, and 2 is of course in between -5 and 256, that object 2 gets cached in memory. Meaning, if we were to do id of num1 and id of num2, these would return the same value because we are referring to the exact same object, which is the cached object 2. Remember, check if operand is the same object in memory. Since any integer between -5 and 256 is cached in memory, any variables that we assigned a number within that range is going to be automatically referring to the same object. Meaning if we assign 5 to num1 and num2, num1 is num2. However, since we're assigning 300, which is outside of that range, well, those values aren't cached, meaning they're going to get different IDs, meaning they're going to be referring to different objects in memory, which is why num1 is num2 in our second example results in a false. A way of getting around this is if we have num2 equals num1, means we're going to take the reference that is stored in num1 and assign it to num2. So if we print num1 is num2, then that's going to now equal true because they're now both pointing to the exact same object in memory. Something else to note is that you see here on line 53 how we have num2 equals 300. What do you suppose happens to this 300 here? Well, in Python, similar to JavaScript, if there are no variables that point to this object, the garbage collector will come and free up memory because it no longer has any use because nothing can reference this object. The same thing can be done with strings. We have string A equals lowercase a string, string B equals a lowercase a string as well. Print string A is string B, and that equals true. Now, typically I'll use comparison operators when it comes to comparing strings. Here on line 61, I've changed it to string A equals equal to string B. What this is evaluating is if this string is equal to this string here. It is true. Next, we'll cover membership operators. Membership operators check if a value is or is not contained in a collection. Similar to identity, I've come up with a simple sentence to help make this easier to visualize. Check if value is blank a collection, meaning check if value is in a collection, or check if value is not in a collection. On line 67, I've created a list of numbers. Inside of that list, we have the numbers 1 through 4. On line 68, we're going to print is 5 in list A. Referencing our sentence above, check if value 5 is in a collection, list A. Check if 5 is in a collection of 1 through 4. This is going to be false because 5 is not contained in a list of 1, 2, 3, and 4. Same thing can be said of line 70, where we create a list B, which is a list of strings, which contains the colors red, blue, and green. Print the string yellow in list B. This is going to be false. Print string red in list B is going to be true. As we can see, the string yellow is not contained inside of this collection, this list. And on line 22, where we're comparing to see if red is in that list, we can clearly see that red is in that list. Now, this does not only work with lists, it also works with tuples as well. Tuple A is equal to a tuple of red, blue, and green. Print red in tuple is going to result in a true. Similar with not in, check if 5 is not in list A. That is true. There is no 5 in this list. Same thing on line 79. Print red not in tuple A. This is false because, as we can see, red is indeed inside of this tuple. Now, the last operators that we'll be going over are concatenation, and repetition. These will look familiar. What you see here is the plus sign and the star sign. Now, concatenation and repetition operators applies to sequence data types like strings, lists, and tuples. Concatenation creates a new sequence containing all the items from both operands. Whereas repetition, a new sequence is created containing the items of a sequence repeated in number of times. Now, on the screen, I've come up with some more examples. I have the string hello, and I also have the string world. What we're doing here on line 88 is we are printing hello concatenation world, which results in hello world. On line 89 and 90, I'm creating two variables, name1 and name2, and I give them Clive and Jill respectively. Line 91, we're going to print hello plus name1 plus and plus name2. What this results in is hello Clive and Jill. Now, for the longest time, this was the way to print out strings that would contain variables so that you can do things like greetings like this. However, these days in Python 3, you can use what is called an F string, which is denoted by F in front of the creation of a string. So we have hello in curly brackets, our variable, and another set of curly brackets, name 2. And it gives us the exact same output. Now, keep in mind that one of the cool things about Python is this applies to more than just strings. For instance, if I were to change the string to the following. Let's say I create a list of colors of the rainbow, some of the colors of the rainbow, named rainbow colors. I can also use an F string to print some colors of the rainbow, in curly brackets, put my rainbow colors variable here, and the result will be some colors of the rainbow, and it will print out that list with square brackets and all. Lastly, we have our repetition operator. On line 95, you can see I've created a variable named echo, and we're going to assign it the string hello plus 2 O's, and then you see this repetition operator right here, 3. Now, what gets printed out is hello, which we see here, and what this portion here is saying, we're going to print out a lowercase o and an uppercase O 3 times. So we can see 1, 2, 3. There are numerous tools at our disposal. The if, else statement. When it comes to if statements, there can be 0 plus, as in none or many, elif, which is short for else if blocks. And the else block itself is completely optional. If and elif take some expression and executes code based off that expression. The flow of execution is 1. Check the if expression. If the condition passes, execute that code in the block. If not, we move on to step 2. Move through any elif expressions, and if a condition is met, execute the code in this block. If we don't find a condition that passes, then we execute our else block if there is one. The thing to note is you can have, once again, as many elif blocks as you want. However, as soon as we find a condition that is met, we ignore any subsequent statements. We're going to go over some examples now. In this first example that I've created, we have age equals 30. If, which is a keyword, our expression, if age is less than 21, we're going to print out the statement, you're not allowed to stay in this establishment past 11 p.m. Else, print, welcome to Club Escapade. What will you have tonight? Here, I have printed out what the outcome of this will be. Since age is 30 and 30 is greater than 21, we're going to go to our else statement here. In our second example, we're going to go the full gambit and use if, elif, else. On line 19, you see I have a variable created called height in inches, and we give it the value 70. On line 21, we have if, our conditional expression, height in inches is less than 60, which is 5 feet tall. We're going to print, you're not tall enough for this ride, you must be at least 5 feet tall. Elif, 60 is less than or equal to height in inches, less than 84. This statement can be a bit confusing. But what this is saying is that if 60 is less than or equal to height in inches, and if height in inches is less than 84, we're going to print out, you're tall enough for this ride. So we have 70 as our height in inches. So we're saying on line 23, else if 60 is less than or equal to 70, which is true. If 70 is less than 84, which is also true, we're going to print out this statement here. Else, we're going to print you're much too tall for this ride. So basically, if you're over 7 feet tall, and since height in inches once again is 70, we're going to print out you're tall enough for this ride because we fall into this block here. Now, as stated before, when going through our blocks, the first condition that is met, we're going to execute this block and ignore everything else. As we see in our third example, I have example 3, multiple conditions met. So if I have age is equal to 21, on line 36, you see I have the conditional statement, if age is less than or equal to 21. This is true. 21 is equal to 21. We're going to print, you're not allowed to stay in this establishment past 11 p.m. But we also have elif 21 is less than or equal to age, and if age is less than or equal to 35. So if you're between the ages of 21 and 35, we're going to print out, welcome to Club Escapade, what will you have tonight? Else, we're going to print, this club is most likely not your style. And as we can see down here, we're going to print, you're not allowed to stay in this establishment past 11 p.m. That's because our first condition that was met, we printed out our statement or whatever code was supposed to get executed, and then we ignored everything else. Now, there is something similar to if, else statements, and that's called match statements. A match statement takes in an expression and compares the value to subsequent patterns given in the form of 1 plus case blocks. What I mean by this is, take a look at the example that starts on line 32. I converted some code for the sake of this example. On line 32, we have match, our keyword, and choice. If you remember from earlier, choice is simply a value that is supplied by the user. We have a number of different cases. Our first case is 1, meaning if the user gave the input 1, our next scene is going to be forest stair sky value. Case 2, we supply a different value to next scene. Case 3, same thing. Next scene gets a different value. Case 4, we exit the code. Now, this final case that you see here, case underscore. Underscore represents our fallback. Essentially, this is the case that gets called if the previous cases, 1 through 4, are not met. We print invalid option, and then we exit the code. Moving on to our section on loops. Loops can come in a couple of flavors, but they're all similar in the sense that given some condition, code executes while that condition is met. The first loop that we'll discuss is the while loop, which is denoted by the keyword while. As you can see on line 7, I have a list of numbers called numbers. In that list is the numbers 1 to 10. On line 8, I create an index and assign it the value 0. On line 9, we start our while loop. While index is less than len numbers. Len is simply a built-in function in Python, which returns the number of items in a collection. Since we have numbers, which has 1 through 10 in it, len is going to return a 10. So what this is saying is, while index is less than 10. Inside of our loop, if numbers and index, remember, this is the bracket notation for accessing individual elements in our list. Numbers at index modulus 2 equals 0. We're going to print that element is an odd number. Sorry, is an even number. Else, we're going to print that element is an odd number. On line 15, we have index plus equals 1. This is a very important line because our condition depends on while index is less than 10. We're going to need some way for this condition to eventually become false. Otherwise, what's going to happen is you're going to have, if numbers at index 0, which is going to return a 1, num modulus 2 does not equal 0, we're going to print 1 is an odd number. And we're going to keep printing that again and again and again until you run out of memory and this program crashes. So, in order to prevent that from happening, index plus equals 1 is going to, once we're done with our statements, is eventually what's going to make our loop end. As we can see on lines 17 through 26, I have taken the liberty of printing out exactly what's going to come as a result of this code getting executed, which is just going to print whether the numbers in that list are even or odd. 1 is an odd number, 2 is an even, 3 is odd, 4 is even, so on and so forth. Our next loop is the classic for loop. For loops in Python iterate over the items of any sequential data type, such as a list or even a string. For example, we have on line 7, the variable colors, which is a list of colors, red, blue, black, gold. On line 9, for color in colors, print color colon color. And as we can see on lines 12 through 15, we're going to print color red, blue, black, and gold. Now, let's go over line 9 a bit. We're going to start with our keyword for to denote that we're creating a for loop. The next thing we're going to give is some variable that is going to hold sequentially the items in our collection. So what this breaks down to is for color in colors, we're going to print that color. So as we're iterating over our collection, over our list, colors is going to be assigned red. We print that statement out. It is then going to be assigned blue, print that color out, black, print that color out, gold, print that color out. As you can see the difference between for and while. With a while loop, we had to create what is going to be our index, and we were charged with how that number gets updated. In a for loop, that's not required, because our for loop is going to automatically iterate over that list, and each individual value is going to be assigned to whatever variable that we created that's going to hold that value. Now, there are some miscellaneous tools, quote unquote, for controlling the flow of your code. Let's go over what the break keyword is for. The break statement is going to just simply break out of the innermost and closing loop. For example, I've created another while loop. I've created an index on line 7 and assigned it the value of 0. We have while true, which under normal circumstances, this would create an infinite loop. However, if we go inside, on line 9, we're just simply printing out the index. We also have if index is equal to 10, break. If not, well, we're just going to simply update index by 1 every iteration. So as you can see on lines 16 through 26, we're going to print index 0, index 1, 2, 3, 4, all the way to 10. Now that index is 10, let's say we're on iteration 9. So index is now 9. Index plus 1 index plus equals 1 is going to now be 10. We go to our loop, we check our condition, which is just simply true. Print index is index 10. Now on line 11, if 10 is equal to 10, break. This is a true statement, so we're going to come in and break, meaning this loop now ends. We also have the keyword continue. Continue just means we go to the next iteration of the loop. Now, remember the code that we had before where we were printing out whether the number was an even number or an odd number? Well, we've simplified things a bit. We're creating a for loop on line 31 for num in range between 2 and 10. Range is simply a built-in function in Python. We'll take in 1 or 2 parameters. What we're saying here is, in the range of 2 to 10, we're going to take every number sequentially between 2 and 10. You can also do something like this. We can just simply give it one value. This is equivalent to if I were to replace range 10 with numbers. Range 10 just takes every integer between 0 and 10, but 10 is not included. So we have 0 to 9. If you wanted 10, you'd have to just put 11. Continuing on with our example, on line 32, if num modulus 2 is equal to 0, we're going to print even number num. Continue, meaning we're going to ignore this and just go on to the next number. So let's trace through this a bit. For num in range 2 through 9, num is going to first be assigned 2. If 2 modulus 2 is equal to 0, print even number num, which is 2. And as we see here, we have even number 2. Now, since we're inside of this if statement here, we have our continue line, which says go on to the next iteration. So now num is now 3. If 3 modulus 2 is equal to 0, it is not. So we're going to print odd number num. As we can see here, odd number 3. We continue on. Num is now 4. 4 modulus 2 is equal to 0, so it's even. Print even number 4. Continue. Ignore this, because continue, once again, just has us go to the next iteration. This goes on and so forth, until we hit our last number, which is 9. The final control piece that we will talk about is the pass statement. What's so special about pass? Saves you some time in the beginning, because pass does absolutely nothing. It can be used when a statement is required syntactically, but the program requires no action. So if I've created a function, which we'll cover down the line, and that function takes in 2 parameters, an x and a y. I don't feel like implementing this method right now because it's simple and there are other things that I need to do. So I just put pass here. Well, if it does absolutely nothing, then why do we even use it in the first place? Because once again, I do not feel like implementing this method right now. See? This results in an error. An indent is expected here. Okay, there's now an indent. Simply leaving it like this is going to result in your code throwing an error. So we put pass here. In this section, we'll start covering functions. Functions are standalone code blocks that perform specific tasks or related groups of tasks. The general rule of thumb when it comes to functions is a function should do one thing and do it well. Why do we use functions? Well, you could put all your code in one file, That's fine for a small calculator app or a small simple web page. But the moment your code evolves beyond more than just a single task, this practice becomes a nightmare to read and maintain. Functions encourage modularity. Think of modularity as taking a complicated problem and breaking it down into something far more manageable. Functions also encourage reusability. If you find yourself rewriting the same code over and over and over throughout your code, you can most certainly add that code into its own function and call it. This practice is called drying up code, aka don't repeat yourself. I have a function that is meant to represent a scene from the text-based adventure game that we're going to make. To define a function, we start with the keyword def, short for define. Next, we're going to give a function name. The function name is then followed by parentheses. Then we indent and we start adding our code. Now, once we've actually created a function, you're going to need to call that function in order for the code inside to be executed. As you can see here, I've defined another function. This is in a whole other file. That function is called getPath, which is, as you can see on the screen here, is a function that's just meant to get the next path depending on choices that the user makes. One thing that you may notice that is different from our previous function is right here. We have what's known as parameters. Now, you'll hear the term parameters, and you'll also hear the term arguments. Sometimes you may even hear these terms used interchangeably. This is of course incorrect because arguments and parameters are two different things. They relate to the same thing, but they're two different things in execution. Parameters can be seen as placeholders. They define our function's signature. A function signature is just simply something that specifies the general information about a function, like the name, the scope, and the parameters. A function can have any number of parameters. We'll go over arguments very shortly. Our getPath function takes in a string next scene. Inside of our function, we see a series of if conditional statements. Right here on line 9, line 12, and line 15 is where we make our function calls. You can tell that it's a function call because you see our function here, the beginning, followed by parentheses. This denotes that we are calling that function. You may be wondering, okay, how do we call this getPath function since it has parameters that it must accept? Simple. As we can see in our main Python file, we have inside of our while loop, we have next scene equals getPath, that function that we just saw, passing in next scene. Remember when I said that there's a difference between parameters and arguments? Remember, parameters are placeholders. They help to define our function signature. The difference between a parameter and an argument, however, is that arguments are the actual values that we pass to our functions. Next scene here in this context is an argument because we have a literal value that is being passed to our function. We have scene enum dot the beginning value. The beginning gets passed into our function getPath. Inside of our function, next scene is going to be the beginning, and that is our first condition statement. If scene equals the beginning, we're going to do a function call to the beginning. And whatever the beginning returns is going to be returned to whatever call this function getPath. In this portion of our lesson, we'll go over classes. Classes and objects, to be more specific. A class is simply a blueprint that allows for the creation of objects. By extension, an object is an instantiation or instance of a class. An object gets its variables and methods from the class that it's used to create it. Think of classes as blueprints, the blueprints to a building. The actual building that gets built is simply an implementation of that blueprint. To create a class is very simple. As you can see on line 5, we're going to start with the keyword class, followed by the name of whatever that class is going to be. So on line 5, I'm creating a class named greeter. On line 6, I created a class variable named name, and I assigned it the string value Ripley. On line 8, we see a special type of method. This is called an init method. Init short for initialization. The init method is called when an object is instantiated and is used to assign values to the variables inside of that class. Works very similar to the constructor in other languages. On line 11, we've created a simple method that's just going to print out a greeting, hello self.name. Now, you may be wondering, what is this parameter that we have called self? Self represents the instance of a class. Instance methods must start their parameters with self, or some variable that will contain the instance of a class. Standard practice is that this is called self. You could change self to foo, your name, so on and so forth, but I think a lot of different IDEs will give you some trouble with that. Your code will still compile and will most likely work just fine, but it's easier to just name this parameter self. You may be wondering, why do you use self? Well, you use it so that you can actually have access to the variables and the methods that are inside of your class. I wanted to clarify a distinction that we're making. Here on line 11, you see I have a comment, and in that comment, I have class method, not function. A method is something that belongs to a class and an object, whereas functions are their own standalone blocks of code. So when we say class method, this is actually a little redundant, because if you're using the term method, you're already implying that you're dealing with a class or an object. Next, we're going to discuss how to actually create an object, and it's very simple. On line 16, I'm going to create a variable named greeter. That variable is going to be assigned an instance of the greeter class. To do that, we're going to take the name of our class, parentheses, any arguments that need to be passed. We're going to pass the name Newt in because, as we can see on line 8 in our init method, our parameters are self and name. Back on line 16, class name, greeter, parentheses, followed by our argument for name. What happens when we're doing this here is we're actually calling this init method. Newt, as stated earlier, is going to be placed inside of name. And inside, we're going to have self.name equals name. Recall what I said self represents. Self represents an instance of a class. So what we're doing when we pass Newt in, this name here is different from the name on the left side of our assignment operator. What this is saying is the instance of our class dot name equals name, the name that we're going to pass in. These are seen as two totally different things, even though they have the same name. Self.name is referring to what we have on line 6. So instead of Ripley, which would be the default value for name, we're going to assign Newt. And what ends up happening once this is done is we're going to have an object assigned to our greeter variable, an object of class greeter. Now, think back to when we were talking about variables before, where you'd have type of some variable, let's say a number variable or a string variable. You had class int, class string, or str. What you're going to get with this is class greeter, because we've now started creating our own classes. So think of ints, strings, floats, so on and so forth. Those are built-in classes. Now we're creating our own. One more distinction that we need to make is, now that we have our greeter object, let's take a look at lines 19 and 20. Greeter.name, this is now an instance variable. An instance variable are just variables that are owned by the instances of a class. We have our class variable, name, is different from our instance variable. To further show this difference, I've added on line 20, print greeter.name. The difference between lines 19 and 20 is the greeter here on line 19 is referring to the object that we've created, as opposed to the greeter on line 20. This is referring to our class, as in what we have on line 5. Greeter.name is going to print out the class variable, which is Ripley, as opposed to greeter.name on line 19. This is going to print out the instance variable name, which we gave the value Newt. You could do something like this here, where we're going to take the class greeter and call its greet method. However, going back to self, you're going to get a warning about the self parameter is unfulfilled. And if you try to run this code as it is right now, you're going to get an error centering around self not being instantiated. To remedy this, you would give an instance of greeter. We already have one created, so we'll pass that in. With this, what do you suppose the output will be? Would it be hello Ripley, or would it be hello Newt? Once again, think back to what self represents. In our greet method, what we're saying is print hello self.name. Since we've passed in greeter, what does self represent? Self represents this greeter object right here. And what does that greeter object have for its name? It has Newt. So what you would be printing here is hello Newt, not Ripley. Back to the question that you may have of why is self needed in the first place? Because if you use this class here and you were to just remove self, as you can see on my screen, now we have some squiggly yellow lines, which shows that we have some warnings in our code. And this warning that we have on line 8 is usually the first parameter of a method is named self. On line 9, method's parameter name reassigned. So what's happening here without self is you're going to start running into some very weird territory. If you were to look and ask the question, what is the distinction between the name parameter, the name variable, and then this name that we're assigning here? What does this name on the right side of our assignment operator represent? Well, under normal circumstances, it would represent whatever argument was passed to our parameter for this init method. Now, where things get weird is what you have on line 9 is you're creating a new variable named name and assigning it name. This new name that you're creating, it conflicts with the name here that we have in our parameter list. Now, you could do name2 equals name, and that's fine. But now you have to change a whole bunch of code for very little gain, if any. If we get rid of self inside of our greet method, well, hello self.name. Well, we don't have self anymore, so we have to get rid of this. But now we start getting an actual error. Unresolved reference to name. Because how are you going to actually make use of this name here? Now we could just simply get rid of the more personalized greeting, but we still run into an error here. If you were to try to run this code as is, you would get a type error. More specifically, type error greeter.greet takes 0 positional arguments, but 1 was given. That would be run on this line here. The reason why, let's break that error down one by one. Takes 0 positional arguments. If we go to our method declaration, as you can see, our parameter list is empty. We don't take any parameters to this method. But 1 was given. Now you may say, well, we're not giving 1 on line 21, but we are giving 1 on line 22. Well, on line 22, you're hit with a warning, unexpected argument. So if we were to comment this line out on line 21, if we were to just comment that out, it would be, but 2 was given instead of just 1. The reason being is because when you're making calls to methods in Python, self or an instance of that object is automatically being passed. It is much simpler to just use self. From my own experience, I can think of no case where removing self actually benefited me. Early on when I was learning Python, I can point to more cases where ignoring self made some code take way longer than it needed to. We're nearing the end of our tutorial, but there are 2 more things to discuss before we go over the actual game that we're here to create. The first thing is files. Now, files are not complicated. Here I have some code in a Python file, scene utils. Here on line 5, we are just simply opening a file. We have our keyword with, which is a means of simplifying the management of common resources like file streams, like what we're using here. Think of a file stream as a connection to a file, a connection between our code and the file itself. Next, we have open. The open function opens a file in whatever mode is specified and returns a file handle. What's provided at the end are methods that can be used to read and write to that file. Open takes in a string, which is the file name. As we've explained earlier, but we'll explain it again here. We're creating an F string that first has our script path, which is defined up here, / whatever scene we're passing in .txt. The second argument is the mode that we're going to be accessing this file. Here I've given R, which just denotes that we're opening this file in read only. There are other modes, so R+ is for read and write, W is for write only, W+ is for write and read, A is for append only, and A+ is for append and read. The next word, as, followed by a variable name, what's going to be stored inside of this script variable that we have here is our connection to that file that I spoke on earlier. Now let's take a look at one of our script files. For line in script means for each of these lines that we have here, we're going to print that line and we're going to strip away any trailing spaces. That's what our strip is. And we're also going to wait on user input, because in order to go to the next line, the user needs to give some input, either a space key, enter key, so on and so forth. The last thing that you'll see here is script.close. What this is saying is close our connection to that file. This is something that you definitely want to make sure that you are doing whenever you're dealing with files. Always make sure to close them. Now, the last thing I want to cover is going to be short and sweet. And that is the concept of packages in Python. Now, this starts to move a bit more into the more intermediate territory. If you look at my project folder here, what you're going to see is a number of different directories. So of course we have our root directory, which contains all of our files. The .v environment folder here, this is just something that's related to virtual environment. We have our game directory, which has a levels directory, which also has a scripts directory. And one thing that you'll notice is this file right here, this __init__.py file. You see this in a couple of different places. You see this in our levels directory, and you also see it in our game directory. What this is doing is denoting a package. A package is a Python module which contains submodules, or, as you see here with levels and scripts, contains other sub-packages. This init file is a file that contains the contents of the package when it is treated as a module. And this file can be left completely blank. Modules are objects that serve as an organizational unit of Python code. Modules are loaded into Python by way of importing. Modules are what fuel code reusability in Python. What we see here in scene utils, this is a module. Scene enum, this is also a module. Pathfinder.python is also, you guessed it, a module. So your modules are your actual files. Your packages are those directories that contain your files. When it comes to importing, as you can see here on line 3, you see the keyword import. Well, this line here reads as, I want to import from the game package, the module scene utils. If we go over here, we have our game package. And inside that package, we have scene utils. Going back to line 3, as utils is saying, we want to import this and give it the name utils, which we can see here on line 11. Utils.playScene, passing in a value. Now you also see on lines 1 and 2, the usage of the word from, as well as import. What this is saying is, from the game package, we want to import from the module Pathfinder this method here, this value here. If we go into Pathfinder, we see that getPath is a method. And that's about it for a surface level explanation of modules and packages in Python, as well as importing. So the moment we've all been waiting for, let us go over the text-based game that we are going to create. Now that we've covered enough of the basics, we can begin making our game. Text-based adventure games have been around since the 70s. Some popular ones include Zork, The Hitchhiker's Guide to the Galaxy, and Planetfall. A more modern example would be Slay the Princess. A text-based adventure game is a great way to explain the concepts that we've learned in this video. To make these games, we utilize a number of the concepts that we've gone over. We need to get input from a player and output the results to said player, so we learn about I/O, or input and output. We need to determine what path the user goes down based on their input, so we have conditional statements. If said input is wrong, we need a way for the user to have a do-over, and loops is one way of doing that. We'll need to store user input and what the next scene is, etc. So we need to make use of assignment operators. To name a few things. We'll begin going over the game by going over what we have here on line 14. Now this is a common line that you'll see if you go through reading a bunch of Python code. If __name __ equals __ main __, try saying all that 5 times fast. So what we have is, if our main.python file is run as a script, which is being run as main, what we're going to do is call our first function, start the game. As you can see, that is defined up here on line 6. And what happens is on line 7, we call utils.playScene. And we pass it the introduction value from our scene enumeration file. From our earlier discussion, we know that this utils represents the scene utils that we import on line 3. If we step inside that file, what we see is we're going to open a file, a text file. What is that file? Whatever is in game/levels/scripts, whatever the scene is. And since we just passed introduction.value, we can come over here to our scene enum class and see that introduction has the value intro. So what we are going to do is we are going to open the file in this directory here, intro.txt. And as we can see here, it's just simply the script that's going to be played out to the screen to the user. We have a number of different files like this. Back in our main Python file, we've started the game and that scene has played out. So what happens next is, here on line 13, we create a new variable called next scene. Next scene is going to equal the beginning value. Clicking inside of there, we see that we're going to pass the _beginning as the value to our next scene. On line 15, while next scene is not none, next scene equals get path passing in our next scene. We've looked before and we see that next scene is currently equal to the _beginning from our enum file. We pass the beginning into our get path function. This is something that we import from our Pathfinder module. Inside of our get path function, we have a series of conditional statements. If next scene is equal to the value of the beginning from our scene enum, here on line 9, what we're going to do is call the beginning function from our forest level module. Whatever this function returns is what we're going to return as our next scene here on line 16. Stepping inside of the forest level Python file, before when I mentioned scenes, what I've done with this code is I have represented those scenes that are found throughout text-based adventure games. I've represented them as functions. So we have a scene called the beginning, which is a function. We have a scene called Stare at the Sky, which is another function. And our moon level file has the same thing. So the first thing that we do in each of these scenes is we, of course, play out the scene. What we do is we make a call to our utils module and make a call for the play scene function. Each of these scenes first makes a call to our play scene because we first have to actually show the user the scene. And as already noted, those scenes, their scripts are stored inside of text files. Once we've played out the scene, we need to get input from the user. Here on line 13, I've created a variable named prompt. And inside of that prompt is going to be stored a string that contains the options that the user can pick. For our beginning scene, they have 4 options. One option is stare at the sky. Second option is get up. Third option is listen closely. And our fourth option is just a way for them to close the game if need be. The next thing we do is we need to store that user input. In our utils module, we have the function getUserChoice. We make use of the built-in function input, which reads a string from the standard input. We're passing in the prompt that we created before. And what this is saying that we're going to put that prompt onto the screen, our options 1 through 4. After that, we're going to wait for that input from our user. Whatever they decide to input is going to be stored inside of choice. Now, anything that comes out of this function here, while that choice is equal to either an empty character or is an alphabet, we're going to continue to, on loop, print out the statement, invalid choice, try again. And then we're going to give the user the same choice over and over and over again until they input the type of input that we want. Once we have that input, we're going to return that choice that the user gave. That choice is now stored inside of our choice inside of our scene. We need to determine what the next path is, or what the next scene is. So we have our match statement here. Match on choice, and we have a number of different cases. Case 1, we're going to move to the forest stare sky scene. 2, we move to the forest explorer scene. 3, we move to the forest listener scene. And 4, we just exit the game because this is our option for closing the game. Now, if the user gives some other input, essentially any number less than 1 or greater than 5, that is also an invalid input. So we just exit the game. Each scene is now going to return the next scene. Based off whatever option that the user picked, we're going to store that inside of our next scene variable inside of our main Python file. So next scene will get overwritten with the next scene. As you can see, our loop here is very simple. We just keep on loop, getting the next path until we hit a none. And that's going to be essentially once you've reached the end of a path. Once they've reached the end of the path, we print out a simple statement for thanking the player for playing the game. And now, let's close up by actually playing our game. In this game, your objective is to simply leave the forest. Of course, it won't be that easy. You'll have to play the game to find out why. To advance the text on screen, press Enter. To choose your path going forward, simply enter the selection by the corresponding option. With all that out of the way, good luck and have fun. You awaken lying on the ground. It's soft. Your mind feels hazy. You find it hard to concentrate on any particular thought. Your vision is slow to adjust, but you make out the scene before you. Your eyes adjust to see the full moon and the stars. Your mind is clearing up now. The moon looks closer than it should. The glow of the moon isn't quite right either. You look around to notice you're in a forest clearing. They don't look familiar. It's quiet. We'll go with option 1. You continue to stare at the sky, focusing on the moon in particular. The moon still seems off. You study the moon. There's a bluish tint that's almost barely there. You stare long enough for your eyes to protest. You blink. Your breath gets caught in your throat. A trick of the mind? It looks like the moon popped back into its previous location. You sit up abruptly. Panic growing. The moon is shimmering. The bluish tint becoming more profound, more intense. The hazy feeling you experienced before is back. Before long, that hazy feeling becomes an intense pain. You're on the verge of passing out. We're going to select option 1. You succumb to the pain. You awaken to find yourself lying on the ground. Except this time, your inspection of your surroundings reveals silver sand as far as the eye can see. You look up to see a strange, unfamiliar sky bathed in odd blues and purples. In the sky you see the moon? No, that can't be. It looks more like the planet you should be on. You don't have time for confusion, however. You scan the horizon and see fog. Standing, you scan the horizon a bit longer, where you make out figures. They're coming towards you. A chime rings out in your head. You start to feel a numbness take hold of your body. You must make a decision now. The figures on the horizon are getting closer, and their outlines look horrifying, intimidating. You decide to run, and we're met with the message, "To be continued. Thanks for playing." And also, if you made it this far, thanks for watching. Hopefully you found this tutorial helpful. Be sure to like, comment, and subscribe to Tech Construct for more tutorials such as this one. If you wish to download this code, I'll post a link to it on my GitHub page for this channel. With all that being said, once again, I hope you found this useful. Have a good evening, morning, or whatever time it is. Have a good day, and take care.